Welcome everyone to the Simio Solutions series. My name is Dan Vasilini. Let me switch over to my next slide. Today's session is going to be best practices modeling labor. Once again, I am Dan Vasilini, VP of Global Sales here at Simio. Doing most of the talking is going to be Drew Rose, one of our solution engineers based out of our Pittsburgh office. A few housekeeping items before we get started. Please be aware that today's session is being recorded for replay purposes. So if you'd like to go back and watch this session or rewatch this session or recommend it to a friend or a colleague, it will be on Simio's webpage. After our session ends today, usually we have it up in about anywhere from 12 to 24 hours. Be aware also that all participants entering will come in today on mute, and you will remain on mute during the entire session to keep the background noise to a minimum. If you have questions that you'd like to ask today, there should be a GoToWebinar dashboard somewhere on your screen. On my screen, it's on the right side. If you've already moved it, it might be somewhere different on your screen. In that GoToWebinar dashboard, there should be a question or a chat area. Feel free to type any questions you have along the way in that area. Today's session is scheduled to last about 60 minutes. We did do a dry run, and the presentation probably will take up the entire time, so I'm trying to limit my talking here at the beginning. If you do have questions, like I said, please type them in, and we will try to leave time at the end to answer them, or we will break in along the way. One update from last week's session, or from last time we were together, or if you've actually watched our session on video, or you're watching this on recording. Currently, we have one more series on the schedule right now. That will be 2 weeks from now on July 14th, and that's optimizing a manufacturing cell. We had a session scheduled at the end of July, but because of vacations and everything, and it seems like from a pure customer perspective, what we're going to do is we're going to have a session in the middle of August and the middle of September before we get back to our bi-monthly calendar. So be aware of that. And also be aware if you do have suggestions or anything you'd like to see in a potential future session, we're always looking for suggestions, so feel free to reach out. And my email address is right there. Anyone else you talk to at Simio, you could always say, whether it's your account manager, whether it's someone on support, whether it's one of our solution folks, you can always say to them, hey, look, I think this would be a great topic for one of your solution series, and we are more than happy to try to potentially put one on the calendar. So one last thing on my side, Simio Sync 2022. We are officially scheduled for Tuesday, October 25th. It will be a one-day virtual conference. Right now, we're finalizing our theme. It'll be a to-be-announced theme here shortly. Registration for this year's event is starting to be opened at simiosync.com. So for anyone who's attended one of our past Simio Syncs, whether it was in person or whether it was on one of our virtual events this year, or the October one will be virtual again. It'll be a one-day event, and you can see some of the speakers that we currently have on the docket. That's it for me. I'll let Drew take over. Drew, the presentation is yours. And you're on mute, don't forget.
Very good. Thank you, Dan. All righty. Well, hello, everyone. Thank you all for joining. As Dan said, my name is Drew Rose, and I'm a solutions engineer here at Simio. And I'm happy today to talk about labor. So, as I'm sure many of you know, in any of your industries that you work in, labor is the lifeblood of your operation. And when it comes to modeling, we don't want to de-emphasize the importance of that there as well. So today I'm going to talk about labor and how there's some potential tips and tricks you might be able to use in your models so that we're getting the most out of labor within your model. And to do that today, we're going to talk about a few topics that are going to be pertinent to Simio, and then we're going to show the use of those by telling a story in a manufacturing operation. So the topics we're going to cover today, we're first going to look at work schedules. And in Simio, as you may or may not know, there are a few different ways that you can have work schedules be built. So we're going to look at a pattern-based schedule, a table-based schedule, and then applying exceptions to those schedules in the event that there may be extenuating circumstances that change what the schedule was intended to be. In conjunction to that, we're going to be applying off-shift rules to our workers so that when work is being handed off from one task to another, there's going to be different conditions governing that policy. As well as we're going to incorporate the concept of worker efficiency. So there may be various levels of competency to perform tasks by your workers in the facility, and we want to capture that in our model. as well as we want to have a better selection policy for when our operators are going to perform tasks. We want to make sure that there's a policy in place that's there selecting the optimal task fit for them. And then lastly, in the event that you may want to manipulate your work schedule in the middle of a model run, we're going to show how that could potentially be used with some process logic. So as I prefaced those being the topics we're going to cover today, we're going to cover those using this manufacturing operation that's going to be looked at in Simio. So before we get into the model and into Simio, I just wanted to give a few assumptions, a few precursors, so that you have a little bit more context when looking at the model. So in this facility that is an adhesive manufacturing operation, the assumption is that this is a 24/7 production facility with 4 manufacturing centers. And the manufacturing centers all have similar machinery, but maybe the bit more intricate in one area from to another. And then at each of these manufacturing centers, there are going to be 3 unique products specific to that. So 12 products in total that you're going to see. And although the machinery is different at each area, we're going to assume that the 5 tasks that are performed at each area are the same, with just various levels of times and different aspects applied to them. But what the operations are at their core will remain the same. And then once they're all made, all the products are made at their manufacturing center, they're going to be rolled up into a universal packaging center where they're all packaged and sent to the warehouse in the one area. So that's a perspective from the machinery side. And then we're going to talk a little bit about the workforce as well. As you know, this is a modeling labor talk. So we're going to incorporate a workforce that you're going to see that has 5 different qualification tiers of skill. So ranging from some of your beginning workers in the facility that are maybe still going through training, still pretty new to the facility, to your senior representatives of your facility that have many years of experience and are qualified to operate any and all machinery in your facility. And then with those qualification tiers, we're going to look at how they may be more efficient at different tasks. So you're going to see some material handling going on today, some packaging tasks that are lower on the pecking order as far as the skills needed to perform those tasks. So maybe we'll see that our veteran workers are a bit more efficient at operating those tasks. And then, as I said, since it is a 24/7 operation, given the nature of these products, that there's within the adhesive, maybe there's some curing or some particular conditions that require it to be 24/7 coverage. We're going to look at a 4-team schedule where first we're going to have the existing facility operate on a 3 8-hour shift policy, but then management is also considering what if we want to look at 2 12-hour shifts that are covered by these 4 teams. So that was just a little table setter from what the facility is going to look like. And then here's going to be the reason why we're modeling today. So imagine yourself as the industrial engineer at this facility, and management is coming to you and they're tasking you to identify ways to increase throughput by making better use of the workforce. So we're going to explore that using those tips and tricks we talked about before. And then management also wants to thoroughly understand the operational impact of what we're proposing before they go and do some foundational change. And you can imagine what the cultural impact would be and the feedback from your operating staff if they went from a 3-shift operation to a 2-shift operation. There's real life implications there. We want to make sure that we're focusing on the operations today. And also we want to explore, and we're going to consider that we're going to be looking at operational improvements prior to considering any additional capital investments. So we might see some results today that may say, let's get additional equipment, but that's going to be not the top priority today. So now that the slides are done, let's get into the model. So I am going to cut my camera off here and we're going to get going. Let's escape. All righty. So here's a little model I put together, and as I explained a little bit, this is the general layout of what we're going to be looking at today. So you'll see the 4 manufacturing operations here. We have these different titles: SS mixer, DS mixer, TS mixer, reactors. These are our 4 manufacturing centers. You can just assume for your purposes today that each of these areas are similar in nature to what the product is coming out to be. They just have various levels of complexity. So you'll see that they all are in this facility, and then there's the Universal Packaging Center. And before we really dive into any details of this model, we're just going to click run and just give you a quick snippet of what's going to flow through here. So you're going to see at the start, we had parts come in, they run to their mixers, they're processed for a certain amount of time. We're seizing workers, move to a packaging, move to the warehouse. So nothing too crazy going on from a model flow. This is just going to give you a little familiarity before we really unpack some interesting stuff with this model. So I'll just stop that. All right. And as you may have seen in previous solution series videos, we always at Simio like to have a data-driven approach. So that's the foundation on which this model was built as well. And so we're going to take a look at some of the data first and kind of show how I went about building this. So you'll see, if you're familiar with the ISO 95 templates, this follows somewhat of a similar pattern. I have just adjusted things as needed to support this chemical operation. So, and I imagine any models you may be doing in your industry, you're going to have things unique to you as well. So we're going to focus on just a few of these slides today. You're going to see all the work cells were built off of this thing here. So each thing is going to be considered as a mixer, and they're universally built in that sense. And then all of the machinery was generated from this slide. And then we're going to have our workers table. So this is where a lot of that information I mentioned in the slides is going to be captured. So you'll see we have 4 worker types rather that are common across the facility. But you'll see we have explicit references to maybe an A, B, C, and D that are four specific iterations of that particular worker type. And we have to do that because since we have that 4-team system I mentioned, we need to have an explicit reference to a particular worker to capture that one team that they're a part of. So you'll see in this worker schedule column, there's going to be plan A, plan B, plan C, plan D. Because they are all operating on different work schedules, we need to make sure that we have a worker able to be specified for that given time. And then the other thing we'll see is we have these qualification tiers here, as I mentioned. You have going from your material handlers that may have a tier 1, and they all go up to your shift leads that are a tier 5. And then also we're going to look at some of these handling efficiencies. So you'll see your shift leads have a higher efficiency to perform any material handling task. So any task in the facility that calls for material handling, and it happens to be a shift lead that gets selected, this is going to be a multiplier for what that processing time is called for. And basically what these zeros here are also doing is kind of eliminating these workers from possible selection for that task. So you'll see, as we'll get into it a little bit more, only the shift leads are able to have reactor efficiencies since they're going to be the only ones qualified to operate in that area. So we're going to do that. And then here is where all of the processing tasks are hosted. And here's kind of where some of those references to those tasks are mentioned. So here's kind of those 5 tasks I mentioned before. Each mixer in the facility is going to get cleaned. Material is going to be staged for processing. We're going to load powder. We're going to load chemicals, and we're going to mix. So pretty simple, and that's going to be common across the board. And then just based on what product is being made, there may be some nuances to that as well. But we're not exactly going to go into the details of that for today's model. And then just a few more things. You'll see that those qualification tiers that I hinted at previously, those are called out here so that when workers are being selected for tasks, there's a selection condition that states that you must have a tier of X to be able to perform certain tasks. So that is especially particular in these batch makers. You might wonder what batch maker 1 and batch maker 2, what's different there. You'll see that they have a slightly different tier for task selection. So there's a few operations in the facility that require a bit more level of experience to be selected that are particularly pertinent to batch making. So that's just a little distinguisher there. So yeah, you also see the qualification tiers is kind of governing who gets selected for what. So with all that being said, that's just a little bit of qualifying what we're going to look at today before we really start to get some testing done. So as I have it set up now, we're going to imagine what's being performed now is the current state. And then as we run this model, we're going to start to think through what are some approaches we can take to start thinking of how we can better use this workforce as per our objectives. And then as you also see here, we have a floor label, and the two metrics that management has identified as key is they want to maximize throughput, but also want to be conscious of the labor cost per batch. So basically this labor cost is being calculated so that when a task is being performed and a worker is performing that task, the hourly wage that is assigned to that particular worker is going to be rolled up on that particular batch as they're being performed for different steps. So each of the 5 steps is going to have a cost associated to it for the labor needed for that, and that's going to be captured in this metric. And so, I mean, obviously you can look at a number of different things, but a lot of the different statistics are available. That's what we're going to focus on today as our drivers for decision making. So we'll initialize as we saw before. We're just going to fast forward here. And you also see that for our run setup, we're going to assume that today is the starting date for when we're going to run that model. And we're just going to run it until next Friday, July 8th. So a short period of time, but should be able to capture the nuances that we're looking for today. So when we fast forward, we see throughput 167, that's assuming 167 batches of material were produced, and the labor cost per batch close to $100. So that's what management sees as the current state, and that's what they want to improve. And the first thing we're thinking of is, okay, where do we go? Where do we begin? And as I mentioned before, what management first thought was that maybe we should go from 3 shifts for a 24-hour coverage to 2 shifts. So let's first consider that. That's where we want to go first. So to do that, we're going to use the work schedule tab in our data ribbon. So as I mentioned before, there are 3 approaches that you could potentially use for work schedules. We're going to look at 2 today. You could also potentially build a work schedule using process logic, but it's not quite as robust as these 2 would be. So the first one we're going to look at is a pattern-based schedule. And for the sake of time today, I'd already built it out, but I'll talk a little bit about what goes into that. So for the pattern-based schedule, you first need to assume that how long do you want your particular work schedule to run for? So you're going to have a pattern that is going to roll over for that number of days. And for this particular case, this metropolitan scheduling plan, that is how you staff a 24-hour operation with 4 teams of 8-hour shifts, that's what we're going to serve as today. So while the particular schedule itself, kind of how the shifts are operating, is a little bit out of the scope of the decision-making within Simio, we're just going to assume that that's the schedule that was in place. So first, when you're making a pattern-based schedule, you're going to build out the day patterns that are consisting of that pattern. So you'll see that we have 3 shifts, and we're going to explicitly state the periods of time during that shift that the workers are to be on shift. So you'll see they start at 8:15, work for 2 hours, end at 10:15. And then there's a 15-minute gap that they're not explicitly stated to have a value. So we are assuming any point in time that isn't captured in this day period, the worker is going to have 0 units of capacity, is going to be considered off shift. So we do this for second shift, we do it for third shift, we do it for first shift, creating our 24-hour coverage. And you'll also see this is a particular nuance of our model today, that the schedules don't directly butt up to one another. You'll see that the end time of first shift is 7:45 a.m. and the start time for the second shift is 8:15 a.m., leaving a 30-minute gap. And that's because in this scenario, we're assuming that from 7:45 to 8:15, second shift has arrived, first shift is finishing up their shift, and there's a shift meeting that is occurring where they're handing off notes, state or current state, and they're getting data for the next shift. So in my time in the manufacturing experience, this is a common practice, and that's a reason, one potential reason for why management is looking at 2 shifts to cut down on the number of shift meetings that occur. So while they're necessary, they're also non-value added time. And if we minimize that, we could get some efficiencies there. So a little bit of information on the day pattern there. And then based on those day patterns, we apply those to the schedules or to the work schedule for the period. So as I said, given this is a metropolitan scheduling plan, workers over an 8-day period, they'll work 2 days on first shift, 2 days on second shift, 2 days on third shift, and then they have the 7th and 8th day off. And then after those 8-day periods, they roll back over and the pattern begins again. So you'll see the 4 shifts all have coverage. You'll see that every shift every day is covered by at least one shift, and they are operating in that manner. So once we have this explicitly stated, we will go, and since we have our worker information contained in the table, this will be stated here in the work schedule column. And also I won't explicitly update these on the work schedule itself. Prior to this webinar today, I've built data connectors that are importing worker schedule information from Excel spreadsheets just for the sake of time. So that's, if there's more supplemental information online, Simio, if you want to explore how I use these data connectors, but that's going to be how these was populated. So since this was already the standard, nothing is going to change from the production there. So we're going to run it again, and it's going to be the same thing. But now that we've already run it and already know the results, we want to consider what 2 shifts is going to look like. But also at this time, we've decided maybe as a modeler, we've learned about the data-driven approach, and we want to start to transition as much information as possible to data tables. And the way we can do that effectively within work schedules is by taking a table-based approach. So you'll see on here, there's 4 work schedules, much like the pattern-based, but you'll see that they're all referencing, there's going to be a lot of row references here and table references on this column. So before we get into a table-based work schedule, you first need to spell out the schedule in a table itself. So you'll see in my list of tables here, there's 4 tables here as well, all that are stating a work schedule. So we'll kind of talk about some of the similarities and differences between the 2. So you'll see, much like the pattern-based schedule, we're stating when something's on and off. You'll see the times are slightly different here, just since this is reflective of a 12-hour shift now, as opposed to an 8-hour shift. But it is functioning the same way, where the times that you want to be on shift, you are explicitly stating those times. And then the other nuance is that you're stating a specific date as opposed to a pattern, and it being considered day 1 versus day 1 being June 27th. So there will be explicit states on dates, but there is a lot of, as you can see, you can integrate this pretty seamlessly into data tables. And depending on where you are in your modeling journey, if you have information like this on work schedules contained in your enterprise data, this can be easily importable into Simio. As you've seen with a lot of this information, that's always what we would prefer, is to have your enterprise data be driving the model. So a lot of power can be used there if this is something that is contained within your enterprise, and you can populate this into Simio. So we'll just assume that all of these schedules are built out. And then when we go to make the work schedule, I will stop the model here so we can take a look at these columns. We'll see that to populate the information on this work schedule, we'll start making some table references. So for 12-hour day A, we're going to look for that. We're going to call out that table, and then we're going to call out the specific column within that table. So pretty important that you have the proper columns for that. And then the other thing you'll see here is this interval function. This interval function is acting the same as the day function on pattern based, in that it is a period of time that you're going to have this work schedule assigned for before it rolls over and restarts itself. So even though you've only in this case explicitly stated June 29th to July 10th, after a 14-day period, this schedule will roll over, and those next 2 weeks will be filled out and assumed to have the same schedule. So it's pretty nice to have that, even though you can call out as little or as much time as you want for your dates, and then depending on what you set your interval to be, you can kind of get that similar pattern from one thing to another. And the other nuance I want to bring to the table is that one thing that is a little bit limiting with pattern based is that you can't have a pattern or a day pattern go across days. So initially I had the start time the shift was to start at 6 to 2, 2 to 10, and 10 to 6, so that you would be kind of crossing over midnight. Within a day pattern, you can't cross days. So I would have had to been 10 to midnight, and then I'd have to figure out another way to do that. Whereas table-based, you can state whatever period of time it's available for. You don't have to worry about crossing over days, things like that. Makes it a little more user-friendly in that sense. So I always prefer to use table-based just for that, and also for the data-driven approach. And the other thing you'll see here is that we have this exception table reference. So given that this is going to be pretty topical, specific to the date of the talk today, given that this is a holiday weekend coming up, I can imagine many of your industries are probably not going to be working on Monday, and we want to make that known in our model. So we're going to build this exception table, and we're going to stay from July 4th, midnight, to July 5th. We're going to have no availability. So we're going to have this say that when we apply this to our work schedule, it's going to shut off the availability from that point in time, even though the pattern or the table may call for availability on that day. So within the table-based, much like you're making the initial table, you'll call out the table itself, the start date, the end date, availability, and it is going to make sure that there is an off shift period at that point in time. And for the pattern-based, to do that is you'll have to make a day pattern for that off time. So in this case, I made it a generic vacation day, 12 a.m. to 12 a.m. to 12 a.m. Don't specify what day it is, but then on the workday exceptions in the drop down here, that's where you explicitly state which day that is to occur. So you'll see on July 4th, we're going to use the day pattern of vacation day, which says for that whole 24-hour period, we're going to be off shift. So pretty nice if you have your holiday schedule at the beginning of the year, you can integrate that. You can make sure that depending on your modeling horizon, you can have that built in for a holiday schedule. It can be anything that's going to be off shift that may be irregular from what a pattern or table may call for. So we're going to look at what since we have built the table base for 2 12-hour shifts, we're going to look at the implication of that. So to do that, we're going to go here. We're going to go to our data connectors. The initial configuration was for the default schedule. We're going to have the configuration be, we're going to import the 2-shift model. So we're going to rerun that. Fast forward. Okay, and you'll see the costs, which as we go, we'll build out an experiment here, and we'll talk about these other controls as we go. But we're going to we have our default run. We'll have this be built out. That's going to run for a period of time. Let's go here. Always nice to have a lot of processing power. These experiments can get pretty computationally expensive, but you'll have, just so we have direct comparisons to one another, we'll show that we would start one shift and then you could experiment with another shift. But for the sake of time, we can always reference back to this experiment list that we have at the end that's going to show the results of running different experiments with different things that we're going to look at today. So we're going to see that, as you mentioned last time, the labor costs have dropped a little bit, but correspondingly the throughput is a little bit different as well. And at the end, we'll really dive into the analysis of each and kind of see what changes are being made. So with that being said, we now are at a point where we've considered a 3-shift schedule, or a 3-shift schedule and a 2-shift schedule. And we've kind of taken a look at, okay, what are we going to get there? And we get some results, still not sure, we're still not convinced. We want to look, we know there's more to do with our labor force. So the next thing we can do is we can get a little bit smarter about how we're selecting tasks. So as we saw before, we have qualification tiers of workers, we have efficiencies of workers, and we want to make sure that our operators, our highly skilled shift leads, are not being selected for tasks that can be performed by maybe our starting out workers. So because of that, we want to have some smarter decision making on who gets what task assigned to them. So to do that, we're first going to have, since right now we have this control on the model, this dynamic selection rule, which is saying when you go to one of these workers and they have a list of tasks available for them to pick from, what's the decision making that decides what task are they going to pick? So with it initially being none, you can assume that there's not really a lot of logic that goes into who does what task. And you can imagine it's 10 operators and they're all doing the same thing. That's basically how our workforce is functioning prior to making any dynamic selection rules. So if we go and we adjust this to get a little bit smarter and a little bit more particular about product selection, equipment selection, we think we can start to find some value there. So we're going to do that. On the control here, we're going to now select largest value first. What are we selecting largest value of? We're going to look at candidate entity. So entity being a batch and the priority of that batch. So if we take a look at our product list, we see the 12 products we mentioned before, and we see that various products have various priorities. You'll see that reactor batches, high priority. These are always based on that condition. Anyone that is filtered down to be qualified for that task, which the qualification tiers filter it down to only being shift leads available to select these tasks. They will see these first and they will grab these first because these are the highest priority, as opposed to before you see a shift lead that's available, it sees 4 products, it's going to grab one based on the default settings. So we assign this. And we saw before throughput was about 200 or so, labor cost was 73. Let's see what happens here. Oh, we see a little bit something happened here. I'm going to save that. We're actually going to save that here. We're going to reopen this. We have a object reference that may be a little bit funky there. So we're going to quickly shift here. Bear with me real quick.
This is the part where I jump in and fill the dead air. So if yours, as I mentioned earlier on, if there's any questions that pop up, please feel free to type them in. We've got a couple of questions that have come in so far. I was trying to hold those off until the end, until Drew gets to that point of answering questions. So please feel free to keep typing the questions in. Looks like you're back up, Drew. Are you good?
Yep, should be good to go.
Perfect.
Okay, so a little bit of must be sometimes the computer is on the holiday weekend ahead of time before us. So we've made the condition that we want largest value first selected, and it's going to be looking for that priority. So we're going to run it. There we go. Order initialized. And it's going to fast forward. And we're going to see some improvements there. So throughput went up a little bit, cost went similarly, and we can kind of see what the effect is there. But I guess the other thing you have to keep in mind is that you have things that are kind of working twofold. So, I mean, we're looking at one improvement, one area that may be beneficial to work in conjunction with another improvement. So I think another area that maybe is something that this facility wants to consider is how are they handing off tasks from one shift to another? And we have to take a look at what Simio is doing by default. So to do that, we're going to see that when we go and take a look at the processing tasks, the off-shift rule, so when every task is being assigned to a worker and the worker is working on that task and they happen to change shifts, what is the policy? So these shift transition meetings, what's being discussed there? By default, this is going to suspend processing. So what that will mean is we'll run this again and we'll take a look at our resource Gantt chart. And if you look out from a sec, you'll see that there's some pretty lengthy periods of time in this Gantt chart where an entity is sitting at a particular step, and we're wondering why might this be occurring. We see that for over the course of a few days, an entity is sitting with the material handler at a particular step. And that is basically due to the suspend processing default setting that is assigned to your workers. And what this setting is saying is that when a worker is working on a specific task, so in this case, a worker is mixing, for instance, at TS Mixer D, and that worker goes off shift, that batch, TSA, is going to sit at that mixer until that specific worker comes back. And so the next operator that comes in isn't able to go back to that task and pick that up because that's not who initially was working on that task. And so depending on your policies, depending on your facility, we might not want that behavior. And in this particular case, we're going to assume that any operator can work on any batch as long as they're qualified to do so. So again, I've made a control on the model itself that instead of suspend processing, we're going to look to switch resources if possible. So what that switch resources will be doing is once the second shift comes back on and there's a person that's qualified to take that job, it's going to attempt to hand that off. So we set that. And then that will apply to all the workers in the facility. They will all want to hand stuff off. We saw before throughput's been around 180, costs have been similar. Let's see what happens when we're able to hand things off. We're going to fast forward here once again. And you see pretty crazy difference in the throughput here. We more than doubled our output because we specified that we want our workers to hand work off from one operator to another who's qualified. And then you see a dramatic impact on the labor costs as well. Stuff isn't tied up on mixers as long. Batches aren't waiting in queue. A lot of stuff is able to move through your facility. So we'll go take a look at the Gantt here. And you'll see all of those bars that were there before are a lot of them, with the exception being July 4th, are no longer the case. That'll still sit there due to the exception table, but the rest of the products, you see that they're moving through kind of as you'd expect. Things are going from shift to shift being produced. So pretty dramatic impact from that suspend processing step, changing that to switch resources. So you can just see by kind of tinkering with the defaults, kind of what little change you can get from being a little more strategic on what your policies are going to be. So at this point, I mean, we've kind of got a few different ways to look at, and then if we kind of look in this experiment view, we can kind of see what we can let's take a look at some of the things we've done so far. So we've looked at worker selection, off-shift rules, scheduling impacts. You can kind of see the effect of all of these different things. So you see, we'll take a look at just these as well. Any scenario that has a throughput and a much higher value, we can assume is the effect of the suspend processing versus switch off shift rules. So you can kind of easily compare one another, like what each of these policies is going to do for your expected throughput and the different results there as well. But at this point, we're still kind of going through the iterations. You're talking with management, and they're still not convinced. They think that maybe there's a little bit, they've decided that, okay, we like some of the improvements, but we find that maybe, what if we added additional workers? What if we brought in a few more temporary workers for a period of time that could help with our capacity? So we've already, the challenge is you can do this. You could go to the workers table and increase the population of workers for a period of time. Or another way you could do it, if you only want them to be in your model for a set number of time, is we can go to process logic. And so what we're going to see here is that on the run initialized, we are deciding, do we want these workers? And then that's a model level control, binary in this sense. So before 0, we didn't want workers, or you could do 1, yes, we want workers. We're going to go and we're going to use these create steps that are going to create an entity of a specific type. So we'll see we're going to make a batch maker 1A, batch maker 1B, batch maker 1C, batch maker 1D. You can assume that we've hired in 4 new batch makers to help with this operation. And then also you're going to say, okay, now that we've hired them, what are they going to do next? We're going to use this set work schedule function. And this is a pretty powerful step so that, I mean, in this particular case, we're going to use it to assign workers to a particular shift. But this is the only way within to manipulate a model, a work schedule during its run. So in this case, if you wanted to overwrite some of the defaults we had with our work schedules here, you could use this function. But in this case, we're going to use it to assign additional workers. So we take batch maker A, we use set work schedule, and we're going to assign it to 12-hour days A. And then the same is going to go for this one, this one, this one, a lot of the similar things there. So all that happens, and then we're going to have them delay for a period of time. So we're going to assume that they are operating at the facility for 7 days. And after their week, after they were brought in for temporary, maybe we had a high number of orders for that period of time. We needed to get stuff out the door. We have them for that period of time. We're going to reuse the set work schedule function. And we leave it blank. And by leaving it blank, we are assigning them no work schedule, thereby taking away any capacity that they have. And then they are rendered to be out of commission for that remaining period of time. So a pretty interesting little piece of logic that you can use and kind of really make this custom to your model. It's a pretty interesting tool that it can really kind of be an extension of your schedule if there's some particular nuances you want to explore. So we're going to look once more. We're going to assume yes, in this case, we want workers. We're going to fast forward once more. Okay. And you see before our throughput was 500 once we added the handoff work. Now we see a further improvement if we add more workers. As you'd expect, more workers, more people to get orders out the door, it corresponds properly. And then as along with it, the labor costs also will increase. And so that's something that maybe from a management perspective, you might want to consider. What are our trade-offs? What is the right amount for us, the labor costs versus throughput? So as you can see, we could have done this during the entire model run. We could have had this all set up as an experiment for comparison, but due to the computing power that requires an experiment, I figured that the best way to do it would kind of just be to look at it in hindsight, and we kind of compare everything we've seen and kind of have it all come together. So you'll see that we've explored the differences in work shifts. We can test the suspend processing versus switch resources, and we can select prioritization of tasks, and we can also use set work schedules to add additional workers. And then based on what management wants, we've made our proposal. We can see if we go to 2 shifts, if we decide that we want to shift or hand off work, if we want to prioritize tasks and we add workers, we would expect that would give us the greatest throughput, but may not be the most effective labor cost per batch. So you give management some things to consider. So you can see that maybe we get an additional 17 batches out the door, but we spend a little more money to do so. So you can kind of you can leave it up to your decision makers at that point. What is the biggest decision we want to make there? So pretty cool. A lot of different things you can experiment with, and kind of just shows a little bit of how working with your model, working with your operators, and getting a little bit more strategic on how you're using them and modeling them can really drive some different results that you might not initially expect. So I guess overall, I think we covered a wide breadth of topics that we can really dive into from a modeling perspective, and especially as it comes to labor. And I hope it was helpful. And at this time, I'd like to open up to questions or anything, and happy to discuss further on anything we've looked at today.
Perfect. Thank you, Drew. So you did leave some time at the end for questions. See? All right. We did have had a couple questions that have popped in. As I go through these questions for any of the attendees that are here, as I had mentioned earlier, if you do have a question, please feel free to type it in the question in the chat box, and we will ask it out loud. So a couple questions that popped in so far. Drew, to optimize the model's runtime, should they use Simio or use a conventional or a connection to an external database? What would you suggest?
I guess it's not the great answer, but it depends. I think particularly in my case today, it's much cleaner if you're demoing to people and you're kind of showing it through a prototype. Having it set up externally is going to be much easier than having to go and modify things manually. And so I guess from a computing perspective and a computational power, it may not be all that more expensive one way or another. But where you're really going to bear the burden is if you have a lot of stuff that's manually generated in here and you're constantly going to be updating it within this, versus you can kind of do it outside of Simio and your Excel, where maybe you have some macros built in or things like that, and you can easily manipulate within that. It makes it much more user friendly to do that importing there.
Okay. All right. Perfect. Next question. Is it possible to set up experiments using OpQuest where they would use the workers' schedules as parameters? For example, could they determine the best start and end time for each member of a 5-staff group, as an example?
That is interesting. I guess that would be maybe some self-learning for me there. I guess there's a lot of different maximizing, minimizing conditions, and I guess I haven't applied that to a work schedule this time. But that's something I'm certainly, now that you've brought it to my attention, something I certainly want to experiment, because I can see a lot of value with that.
Okay. All right, so for the person that asked that question, at the end here, I will flash up my email address and Drew's email address again. So if we want to dig into that further, you could reach out directly to Drew. All right, a couple more questions that have popped in as we're talking here. Is it possible to change a worker's schedule during the runtime? So if in the middle of a 2-week period, could they change the schedule from an 8-hour schedule to a 12-hour schedule, et cetera?
Yes, yep, and that's as I hinted at it, that's using that set work schedule function. That's where you would do that. So you don't have to, like in this case, we were creating an entity or creating a new worker, but you can imagine in process logic, a worker comes in and you want to set the work schedule from an old to maybe they want to go from 12-hour day A to you want to bring them to nights, so you can bring them to B. So based on just a little bit of process logic, that's very much accomplishable and often a pretty often application of this set work schedule function.
All right, nice. Next question, are there any benefits to using workers versus other resources in the Simio library?
I guess there is, I mean, it could kind of go a number of different ways. There's, depending on what you determine to be beneficial. I mean, you can model things, you can model seizing resources, you can model workers as resources, and they function similarly to vehicles. It is just dependent on what you would want to do with those. I mean, all of these have efficiencies tied to them. So as it relates to stuff we looked at today, that's all pretty translatable from one entity to another. It's just a matter of what's beneficial and valuable to you.
Okay. All right. We have the question well has run dry. So let me grab control back again here. Let me just flash up the PowerPoint one last time with information on it. So I know I'm not in presentation mode, but I've got lots of things blocking my screen. Let's see if I get to it. Perfect. There we go. So as I had mentioned earlier, if you want to reach out to myself or to Drew, there's our email addresses right there. So for the question that came up, it's drose@simio.com for Drew and dvasaleni@simio.com for me. So if you want to reach out to one of us directly. And then lastly, one thing that was brought to my attention as we're talking here is the question that was asked about OpQuest. So next week, Optimized Manufacturing Cell, we are going, not next week, 2 weeks from now, sorry. We are going to dig into OpQuest in more depth for the July 14th session. So anyone that's currently watching this session today or anyone that might be watching this on recording and you are interested in the functionality of OpQuest, please make sure you join us 2 weeks from now on Thursday the 14th. And I think that's all we have with questions. All right, perfect. Thanks everyone for your attendance today. Drew, good job. Look forward to seeing everyone in 2 weeks. For anyone that's here in the United States, everyone have a good long holiday weekend coming up. Anyone that's around the world, we will see everyone next week or 2 weeks from now. Thanks again, and we'll see you soon. Goodbye.
Thank you all. Take care.